Hello, everybody. Oh, I love these slides. They're brilliant. My name is Claudia Sabon. I'm from the University of Adelaide, and I'm the chair for your session today. What I'll basically do, I'll just tell you that the exits are that way, and I'll give you some other instructions towards at the end of the first session. And I would like for us to take questions after Chris finishes her presentation. And without much further ado, I'd like to introduce Chris Gerfeide from Bespoke, and she'll be talking about inside our AI pipeline, putting the natural back into artificial intelligence. Chris?
All right, can you all hear me okay? Yes? Okay, good. For people in the back, if you do want to move closer, if you can't read the text, the small text there will be some more later, so consider coming closer if you can't read it. But I am super excited to be here today. Thank you so much for introducing me. And I think with that, we can just get started. Okay, so my name is Chris, and I academically come from mathematics and political science, and then I did my master's in computer science. Just before my current role, I was an engineering manager at Amazon Web Services, and now I am based in Tokyo, and I lead the engineering team for a startup called Bespoke that makes a chatbot for the tourism industry. Today, I want to talk to you about a couple things. It's going to be kind of a whirlwind talk covering just a little bit of a bunch of different concepts. So first, I want to go a little bit into how we do machine learning in chatbots and some general use cases there. And then I want to talk about how we move fast while still taking these technical concepts. And the reason for this is because cool machine learning techniques, at least in industry, are not quite enough when you're still trying to even find your place, for example, as a startup in the market. So you need to be able to do things a little bit more, for lack of a less buzzword, agile than maybe some of the things that I did before in academics. And specifically, I want to talk about two mechanisms that we use in addition to machine learning to be able to move fast. And those are humans and a concept we call code hooks. So if there's people who work in software engineering, maybe you're familiar with this already. I'll come back to it a little bit later. And the reason I wanted to combine these all into one presentation is because, for me at least, it's one of the reasons I like doing what I do and working in industry, where we can combine some of the tech stuff with some of the really pragmatic, maybe even tedious, non-technical things. Just for some context first about what the company does, we make a chatbot. Its name is Bbot. It is adorable. And specifically, it's for the tourism industry, as I mentioned earlier. And what we do is we provide a customized version of a chatbot for different locations that have a lot of tourists. So for example, at Narita Tokyo Airport, if you connect to the Wi-Fi, you get redirected to our chatbot, and you can ask it questions, for example, questions about where food is, what sushi we recommend. We have another chatbot that does natural disaster information, because there's a lot of earthquakes and things in Japan. And in total, we have something like 35,000 users a day right now. And when the chatbot doesn't respond automatically, the vast majority of responses are automatic, but when it doesn't respond automatically, we also have a team of chat support operators that can do things manually and talk with users. Now, for the automatic responses, which is, again, the vast majority of those 30,000 users, we are responding automatically to users' questions that they type. The most important or most difficult part technically of doing that is figuring out what the question is. So when a user types something, we need to figure out what they're asking. And most of the interesting technology that we develop at our company is in figuring out what the question is. So I'm going to go a little bit into this crash course of how a chatbot uses machine learning to answer that question. So when we are customizing a chatbot, the first thing that we do is we have humans define what questions and answers we want to be able to support. So for example, This one is for a hotel, for example. We want to be able to tell users what checkout time is. And to do that, we need to define a couple representative phrases for how a user might indicate, oh, I'm trying to figure out when checkout time is, like when is checkout, how late is checkout. And then we also define what the answer is to that question. Then we take especially the question phrasing data, and we want to train a machine learning model so that it can remember what types of questions there are and what characteristics those questions have. So what we'll do is we'll take a group of questions that all represent the same user's intent. Intent is the word that we often use with chatbots. So for example, the intent of the user is to figure out when checkout time is. We will label the questions with the intent, or label, or class of question. And we feed it all the different question phrasings, and then that machine learning model will understand what characteristics, more or less, are part of a question that is asking about checkout time versus which characteristics are in a question that are, for example, asking where the hotel location is. After we've trained this machine learning model, then when a new user query comes, we ask that model, which question class do you think it is? And it will tell us, oh, I think it's a when is checkout question based on whatever the content of the user query was. So it will tell us what the intent of the user is after we've asked that model to predict it. And then finally, once we've figured out what the question is, for example, we know it's a when is checkout type question, we just retrieve that from somewhere. We look it up, for example, in a database. We get the answer to the when is checkout question, and we return that to the user. Because we're simply retrieving the answer from a database, there's not a whole lot interesting happening there. This is called a retrieval-based chatbot. There are a couple other types, but most of the chatbots in industry work this way, at least the automatic ones. Of course, there are chatbots that are all just users, support operators. OK, so this is the high-level overview of how a lot of chatbots work in industry today. It's also, if you've ever encountered chatbot services like Amazon Lex or Google Dialogflow, they also work in this way. So this is all very similar. And again, step one, that's just people thinking of how we'd create sentences that represent certain desires of a user. And number four is just retrieving something from somewhere like a database. So the interesting stuff happens in 2 and 3. And that's where the machine learning comes in. So I want to go just a little bit more into what that looks like. OK, so again, number one was just humans defining questions and answers. Number two was train a machine learning model on question phrasings. So what this actually looks like is we take all of our question phrasings and we group them by their class or label. These are the same thing in this case. And then what we want to do is transform them and feed them into a model so that it understands, again, what it looks like to be a question of the first type versus a question of the second type. And a really common way to do this, and actually both easy and pretty effective for a simple chatbot, is, for example, simply to look at the words in each questions. And you can look, for example, at the word frequencies in each type of question, and from that, understand more or less what these questions might look like. So for example, in a simple case, and you can just do this if you want, in Python, ready-made Python libraries like scikit-learn, we're going to break up each of these question classes into their word frequencies. So we just count the number of words that are present in each question here for each class. And then we train the machine learning model with that information. And then the machine learning model will know questions of where's hotel they mention the word hotel a lot. They mention the word location sometimes. They never really mention the word when. So then your model knows those things about each of your question classes. Then when the user query comes in, we give it the same treatment. Break it up into, for example, a word count vector. And then the prediction step is basically just asking which question class is the most similar to what I just got from a user. And depending on your machine learning model, it will do this in different ways. But you can think of it, for example, as a distance calculation, just like when you would calculate the distance between two xy points in a coordinate plane. You could do the same calculation here. It's just more numbers. It's not xy, it's oh, hi, how, and a bunch of other numbers. But you could do the same type of calculation, and you'd end up with similarity scores or distance scores. And you could decide which of those classes is most likely. And this is exactly what you get as the output of a prediction in a model like this. So the model will tell you, oh, I think there's an 85% chance that this is a where is hotel question, and only a 30% chance that it's a checkout time question. And from that, you just pick the one with the most likelihood, and that's your answer for what the question is. And then we go to step 4, which is boring again, but we take the question that we determined what it was, and we just look up the answer somewhere. So this is high level how chatbots use machine learning. Right now, we just take word frequencies, but again, you can get pretty far with word frequencies, and you can even expand just on this idea. For example, maybe you take pairs of words, so it's the word where next to is that indicates something, and you could tally up the same frequencies for those pairs of words, or you could do similar with letters, or you could treat synonyms where you convert certain words like bookstore to bookshop so that you get even more consistency in your dialogues. So that's the machine learning part I wanted to go over. Again, there are really good libraries that can help you do this. You don't have to even create these vectors of word frequencies yourself with certain Python libraries, for example. So it's really easy to do. And if someone's interested in that, we did a workshop last week in Tokyo, and I can give you materials with sample code and everything if you just want to see simply how you might do such a thing. So that's the machine learning part of our pipeline, which I suppose we would call our AI pipeline. But because AI is a fuzzy word, I like to include the non-human, the non-AI, non-machine learning aspects in there as well. So I want to talk about the other parts that we put into our AI pipeline that I mentioned earlier. And those parts are so that we can do especially experiments quickly. Now, what I mean by experiment is that you can quickly test out an idea to see if it actually improves your product before putting too much work into it. If you're familiar with A/B testing, that's an example of how you can do experiments. There are a couple other ways as well. So for example, we do a lot of tests with what we call the welcome message of our chatbot. So as soon as you log on at Narita Airport, for example, this is the first message you will see, or rather did see. So we had this welcome message that just asks you, oh, what do you want to do? And you could select one of these things. And we did an experiment where we changed the welcome message to be more specific to one of the most common actions that people were doing in our chatbot, just to see what happened. And what we wanted to see is, do people use the chatbot more? So what we changed it to is, do you need flight info? Yes, no. Very direct. And what we saw when we did that is that usage tripled. So we had 3 times as many users using our chatbot when it was a very simple, short question. That's what we learned from that. So these types of experiments give you really interesting data, and they're not that hard to do. We didn't need to develop anything interesting around machine learning to do experiments like this, but we very well might learn things that we can put back into our algorithms based on these things. Now, to carry out experiments like this, we need humans. So not artificial intelligence, but just regular intelligence. And we use humans for a couple different things. We utilize the humans in a couple different ways. So the first one, which is really important, is for designing conversations, because people, at least compared to most robots, are quite good at having natural conversations and thinking about a normal way to say something. The next one is, for example, thinking of the experiments. So making a hypothesis about what might change some user's behavior and then testing it. We also use humans to test out features that we think would be cool, but before putting any engineering effort into them. And the best example that we have of this is, for example, restaurant reservations is one of our most popular actions for hotel users of our chatbot. And so they can ask, oh, what are sushi places around my hotel? We give them automatically answers for sushi restaurants. And then they say, OK, I'd like to book this one at 8. And then we actually have people manually on the support team see that chat and go call the restaurant in Japanese and make a reservation, and then type back to them, OK, I made your reservation, smiley face, emoji, emoji, emoji. And this is because automating that would be really difficult. So unless almost all of our hotel users are using it, it's probably not worth the effort for us to attempt to automate something like calling little Japanese restaurants. So there's still some things we want to do manually, and especially in the beginning when you just have a cool idea, even if it's not that much work to add automatically, maybe you want to do it manually at first anyway, just to see how users respond, in what ways users ask questions. You can get so much information by just having someone sit there and actually converse with users. And finally, sort of a side effect of having a team of chat support people is that you have real people evaluating the performance of your algorithms on the backside all the time. And this is actually a very difficult problem in machine learning to beyond your test sets, where you measure, for example, the accuracy of your machine learning model, to see how it's really working in production and being confident that it's working correctly. So to say that a question was correctly answered in an automatic way is very difficult. It's something we think about a lot. And we are very thankful that we also have humans to tell us, oh, no, this is not working at all. Please fix it. So that's our support operators. So they act as these last line of protection, I guess, for us. Last line of testing for us. So let's look at one more example of an experiment. So again, we're going to look at the welcome message. This is our welcome message after we did that experiment the first time. Do you need flight info? Yes, no. And we had this hypothesis that because we shortened the welcome message so much and it only mentions flight info, maybe we should keep it short, but still improve the discoverability of other features of the chatbot, because people have no idea what kind of questions they can ask us, because we can do restaurant recommendations and where stuff is in each terminal, because we ask the airport's API, for example, locations of different stores, and we can do when your flight leaves, and a lot of other little features. And we were afraid that maybe they just don't know what they are doing, what else they can do. So maybe it will increase the usage if we give them some idea of that. So we made a very simple change. We just changed the last button to say, instead of no, it says no, what else can you do? And again, the goal here is to increase the usage of the chatbot. That's what we want, to see that our users are happy. So let me take a poll in the room. Who thinks the first version, just with no, will get more people to use the chatbot? I think I see no one. OK, and then the second one, no, what else can you do? Who thinks this one will get more people using the chatbot? OK, so that's the majority here. We also do these kind of bets in our team. So when our product manager says, oh, we're going to do another experiment, it's going to be this or this, and then we each bet on which one will get more users. In this case, we were all wrong. So what we saw is that we cut the usage in half when we made this change to the second one. No, what else can you do? And we have some hypotheses about that. And the most important one is that maybe people didn't want to see the chatbot in the first place because they just want to use the internet. And they thought maybe no is how you use the internet. Maybe. Anyway, but we're just going to make more hypotheses based on this and see what happens. Another thing we got in this specific example is if for the people who do click on no, the people in the second case, the new case, were more likely to do a lot more things. So if you restrict it just to the people who click on, how was that? For the people who click on no, what else can you do, but still use the bot at least once, then their actions are much more varied than they were before. Anyway, so there's a lot of really interesting analysis you can do here. All right, so the next non-machine learning technique I want to talk about is code hooks. So code hooks are an integration point within your application that allows you to easily insert some other code path without changing your application that much. So the idea is to make it really easy to try out new code. Before we look at how it works, let's look at why it's an important concept in software engineering. And I'll give another example first. So people talk about a lot of things on our bot, and as a chatbot located in Japan, one of those things is Pokemon. This is pretty common. And what we noticed is that people, in a fair number of cases, were typing sentences like this. And the interesting thing about this case is that the accent mark is facing the wrong way. So most people don't bother to put accent marks on a lot of the words they use. Pokemon is probably one of the few important words for our chatbots in Japan that really needs this accent. But we saw that people were doing it in other cases. So when they use an accent, it's very often the wrong one. So we wanted to fix this and answer these questions more accurately, since before our machine learning algorithm stuff would get a little tripped up if the words weren't spelled correctly, like this one. And so the way we fix this, and actually a pretty common way to fix issues like this, is you take your words and you convert them to a less powerful encoding. So for example, from Unicode, you just convert it to ASCII, and the libraries are pretty smart about converting it to something that makes sense. So removing umlauts and removing accent marks and things like that. So we made that change and we put it in production, and then actually our chat support people said, oh, I think there's something not as good as it was before. So again, we have this first line of defense from our chat support people. And what it turned out was happening is that because we made this change, it was removing emojis, and people love emojis in Japan. So, so what this turned into when we looked into it is when you convert this to ASCII, it'll just remove the emoji. And in some cases, people don't put a space on each side of the emoji. And so it became one word. And then again, this looked like nonsense to our machine learning algorithm. And then it wouldn't be able to figure out what the question is as well. So in that case, for example, we had to do something ideally as quickly as possible to handle this case. And now we have somewhere special cases for emojis that will convert them in a different way before we change the encoding of the string, for example. And then the algorithm works as expected. And we saw the accuracy improvement that we were hoping for when we made the original encoding change. All right, so then how do you do code hooks? Here's a quick example. This is kind of like Java pseudocode. You have some function. It runs your normal algorithm somehow. In our case, maybe it's getting the answer for a user's query. And then you simply add what we call a hook in the middle. This could be as easy as an if statement that says, if feature is enabled, return the result of this other algorithm. So what it should do, if you write this in a nice, robust way, is it shouldn't matter if the new thing fails. The new thing should be able to time out. And in any of these weird situations, maybe it doesn't return an answer. In any of these situations, it just falls back on the old behavior. And in the new code, this is just located somewhere else in your application. Or maybe it's calling a web service. And then you can do whatever you want in, for example, that web service without changing anything about your current code. And specifically, a service that we really like to use for this is Aws Lambda, which is a serverless computing service from AWS. And what it allows you to do is basically, it will give you a web service where you can change the code just by typing in a type box on the AWS console. So you just go to a website, and you can even update the code live, click save, and you don't need to deploy any new services. You can write in a variety of languages, and it makes it really easy to test out really bad code. And for certain things, you just want to know if users like it before you make the code good. So this service is one that we really like to use for that. So for code hooks, they therefore give us a couple different benefits. So the first one is running experimental algorithms, put it in production just for a little bit of time, see what happens. You can also compare algorithms, so you don't even have to return the result or show the result of the new thing to the user. You can just log it. So you can see for all of your production queries that are coming in, you can print out a list of, oh, the new algorithm said this, the old one would have said this, and check all the cases that didn't match. You can run really bad code and see if it works before putting effort into improving it. So there's a lot of cases where it takes a lot of effort to make nice machine learning code, and maybe you don't want to do that at first. And finally, you can use whatever technologies you want. So for example, in the case that I talked about earlier with the emojis, we could test out even using new frameworks. Maybe there wasn't good, for example, encoding support or something in the language we were using, and we thought, oh, let's use a different programming language. Super easy if you're doing something like a web service, and you don't have to touch any of your existing application to see if it's a good idea. So in summary, we have our machine learning pipeline. I think that stuff is really neat. I think it's really fun to think about. But I think I enjoy, I guess, the application of some of these just pragmatic software engineering principles, like using humans or something like code hooks as a design pattern, so that we can really do things very quickly and benefit our users and give them those natural experience by combining these things. And I have some numbers here, but I think I'll just skip those. Basically says we do a lot of AP tests. All right. So with that, I think I want to open up to questions. Again, this is one of the reasons that I moved into industry, I guess, because I like this combination. But I would like to have a couple minutes for questions, if possible.
So we have time for one question. Who's it going to be?
Sorry, just out of curiosity, but if you actually got a tourist that actually gives you like a question that is not part of your predictive categories, will you guys actually keep like a list of it to kind of use it down the road to kind of insert that in your category?
Yeah, so how this works, it's actually very hard to tell when you don't know the answer, or don't know the question, rather. So when you're trying to figure out what the question is, and what your machine learning model is going to tell you is, there's a 55% chance it's this question, there's a 45% chance it's this question, but that doesn't tell you if it doesn't know. And you basically can't train it to know when it doesn't know. So what we do is, for example, you can add a threshold, like if the probability is less than 50% and the deviation between the probabilities is very small, like it thinks it's a bunch of different questions equally likely, then we decide we don't know it. So first that, and then when we don't know it, yes, we review those. So we log those somewhere, and then our mostly R&D team, who does most of the natural language processing and machine learning stuff, we'll store those and look at why they didn't know them. And sometimes it's just that we need to customize with new questions. Sometimes it's that our algorithm didn't match well enough to find a question we do know.
I will ask you, unfortunately, to talk to Chris offline, because we're really running out of time. Thank you, Chris, again. So without further ado, I'd like to introduce Carmel Hinks from Atlassian. She's going to talk to us about iterative metrics, dashboards, and monitors. Carmel?
Okay, hi everybody. My name is Carmel Hinks. As was said before, I'm a software engineer from Atlassian, and I'm here today to speak to you how we were able to move away from a very set and forget approach to the definition and maintenance of our operational resources, and to something that was much more agile and iterative. And so just to give you a quick overview of what we'll be covering today, we're going to start off with a few explanations just to make sure we're all on the same page. And then I'm going to tell you a quick story to set some context. We'll then be taking the rest of this presentation to take a deeper dive into how you can decide what to measure, how you can verify that what you're measuring is correct, and then how you can help your team keep up to date with change. And then, of course, we'll finish up with a summary at the end. But what are we actually talking about today? Well, throughout this presentation, you're going to hear three terms come up a lot, and that's metrics, dashboards, and monitors. But what are they? Well, a metric is just a measure of a software characteristic that's used to understand what your systems are doing. A dashboard is then just a visualization of those metrics, and this can be done in a variety of different ways. And then we have our monitors, where a monitor is an alert that is defined against one or more of your metrics. Basically, they're a way to monitor that your application is still behaving in the way that you expect. And all three of these things come in a variety of different forms, but for the purpose of this presentation, we'll be focusing on those that relate to the operational health of your application. And so I'm going to tell you a bit of a story now about a project that I've recently worked on in Atlassian, and that's because it's very relevant to the content that we'll be covering today. But I want you to brace yourselves just a little bit, because we do have to cover a small amount about how Atlassian cloud infrastructure works, but that's okay. So at Atlassian, we run and maintain our cloud infrastructure on a multi-tenant architecture. And this just means that a single running application can serve many different customers. Now, one of the key components within a multi-tenant architecture is the ability to share resources. So if I were to have myself a Jira, within that Jira, maybe I have a database, some application nodes, and a queue. In order for that Jira to be multi-tenant, I would need to make sure that it's safe for my various different customers consuming the Jira to share all of those resources. Now that's fair enough, but at Atlassian, we actually have hundreds of thousands of customers now, and they're located all over the world. And that means we don't have just one big, huge pool of resources for everybody to consume from, but rather lots of smaller little pools that we call shards. So you can see a shard is essentially a collection of resources that are used to run one of our products. And the idea is that a shard will service a subset of our customer base. And a customer is allocated to a shard when they sign up with us. So they'll come in, ask us for a product, we hand that request over to the provisioning pipeline, all this magic happens, and then a customer ends up on a shard. So if we were to unwrap that magic just a little bit, we see that it's actually just a collection of different microservices all working together. And one of those microservices is called the shard service. So the sole responsibility of the shard service is to select a suitable shard for a customer at provisioning time. And a suitable shard is based on two factors. The first is geographic location. So is the shard physically close to the customer making a request? The second is, can the shard even fit more customers in the first place? And in order to answer that second question, the shard service needs to keep track of dynamic metrics to represent the capacity of all the shards. But I mentioned before that shards are a collection of resources, and theoretically, any one of those resources could hit its limits. And so the shard service for every shard looks at a collection of resources, all of which come from the shards to represent the capacity of the various different resources within the shards. It can then take the limiting factor and uses that to denote the overall capacity of the shard. Right, so everybody now understands Atlassian cloud infrastructure. But you might be sitting there thinking, what the shit? I was meant to be learning about iterative dashboards. The reason I explained all of this stuff is because the primary purpose fundamentally of the shard service was to collect and analyze metrics. And that meant that this project was all about metrics, monitors, and dashboards. And so throughout this presentation, we'll be referring back to the shard service to pull some examples to help explain some concepts that we'll be covering today. And so on that note, let's start speaking about how you can decide what to measure. In the words of Sherlock Holmes, it is a capital mistake to theorize before one has data. And we all know that he was talking about software engineering when he says that, and so we need to go and get ourselves some metrics. But this then lends to the question of what metrics should you collect? And it turns out that's not an easy question to answer, especially in the beginning of development. And we were finding that in the shard service. And we noticed that it would lead to a few different temptations. Maybe we could just measure nothing. And that doesn't sound so awesome, but it kind of feels logical during development because no one's actually using your application. And so we figured maybe it's not that bad if we just add our metrics right before going live. But when we thought about it, we realized that comes with a few trade-offs. To begin with, it would mean that our metrics aren't going to be verified before going live. And that would mean that our first incident was probably going to suck because we probably weren't collecting the right things or using them in the right way. And this isn't even a solution, it's just a deferral of the problem, so that's not so awesome. Maybe we can measure everything. We can collect everything we can think of just in case. And that's awesome because, oh my God, wow, 100% visibility of our application all the time. But again, this has a few trade-offs. To begin with, it's actually really expensive, both in time spent doing that instrumentation and also money, because it costs a lot to collect and store that much data. It creates a lot of noise, and so it becomes very difficult to distinguish what's important from what's unrelated. And it really doesn't scale. So if you start telling all of your developers to remember every single metric if you're collecting all the metrics, that gets pretty old pretty fast. But surely there has to be some kind of in-between, right? Well, we figured maybe we can just measure the stuff that comes out the box. And that sounded pretty good to us because at Atlassian, we use AWS, and so we could get all our metrics from CloudWatch. And that's what we did. We switched them on, got a bunch of stuff, and created a nice dashboard. So on this dashboard, we got some good stuff like latency and CPU, and it all looks pretty good. And then we could define some monitors. So, we don't really want CPU sitting at over 80% for more than 5 minutes. So we should definitely alert. And yeah, that's pretty much it. So operational maturity has been reached, and we can now move on with development. Thanks. And we did that, and we rolled out, and everything was great. But then all of a sudden, we started to receive an alert from one of the other services in our provisioning pipeline. And that was because provisioning had actually started to fail because the shard service had stopped returning any suitable shards. But it was pretty weird because when we looked at our dashboard, it looked pretty good to us. But when we pulled up when we started to investigate the problem, we realized all the shards were full. There were no suitable shards for the shard service to return. And thankfully, this was a pretty easy problem for us to resolve, but it really emphasized that we were looking at the wrong things. And so we decided to take a step back. And we really asked ourselves what questions we wanted to be able to answer with our operational resources. And we found that in order to answer this question, we needed to have a really good understanding of the roles and responsibilities of our application. So we recall the shard service was around because we had to perform the selection of a shard based on geographic location and dynamic capacity metrics. And with this, we could then start thinking about what it looked like when our service's ability to fulfill those roles and responsibilities started to degrade. So the shard service is a synchronous HTTP-facing service. And so that lends to a few fairly obvious things that can go wrong. Maybe the requests slow down significantly, or they're accepted and then fail, or maybe we just start rejecting requests altogether. That all sucks, but it's not really specific to the shard service. But then there's a few things that are somewhat less obvious. Maybe there are no suitable shards, or incorrect shards have started to be selected, or maybe we just don't have enough data to make any suitable decisions. And this really emphasizes the difference between infrastructure metrics and application metrics, where a useful infrastructure metric is something that's tied to a component within your tech stack, whereas a useful application metric is something that's tied to the domain of your application, and only you can know what that is. And so we realized that in order to have a good, holistic view of our application, we needed both. And so we continued to push out our infrastructure metrics, but then we also started to capture custom application metrics as well. And one example of this was the shard capacity. So this is a metric that comes from the shard service to represent the capacity of the shards. And with all of this information, we were able to create 3 dashboards this time. One to give us a snapshot overview of the capacity of all of our shards at any point in time. Another to show us why and how we were selecting shards. And then we still had our infrastructure dashboard because that was still really important information. We then also revisited our monitors. And we realized we don't actually care about CPU because the shard service was not a CPU-intense application. But we do care if our shard or region capacity became exhausted, or maybe if we saw a surge in errors being logged by our application. And so how can you figure out what to measure? Well, we found that we really just needed to understand what questions we wanted to be able to answer. And in order to figure that out, we needed to know why our application existed in the first place and what failure meant to that application and what was the impact of that failure. Okay, so we figured out what to measure. But how can we then verify that we've collected the right things and used them in the right way? We found that at this point, it's pretty tempting to think we got it all right because we just spent all this time answering these difficult questions. But then as time went on, a few things started to happen. Things changed because, we were agile and iterative and constantly working on and developing our application. And that meant that what worked today wasn't necessarily going to work tomorrow. We started to receive a lot of alerts that were either not actionable or just not useful in any way. And that meant that we started to ignore some of them. And we realized that our application had two states that it could be in: completely fine or on fire. Basically, we would never look at our operational resources until something went wrong. And that was a problem because we'd actually defined a service level objective, or SLO, against our application. And for those who aren't familiar with this term, an SLO is just the level of service that you're willing to commit to offer. And again, this comes in a variety of different forms, but one common example is availability. So you could say, I'm going to commit to having 99.99% of my requests succeed. If you were to say that, think about how you would verify that you're living up to that expectation. You'd probably have to look at some kind of dashboard or operational resource, right? And we weren't doing that. We were treating lack of alerts as meeting SLO. And it turns out we weren't the only team doing this. There were teams all across the company who were experiencing similar pitfalls to us. And so we eventually reached a point where we said, okay, this is enough. And many teams, my team included, adopted a process called TechOps. So TechOps is this crazy idea that you should have a process dedicated to regularly reviewing, discussing, and iterating on operational health. And it is worth pointing out, we did not invent TechOps at Atlassian. This is something that's been around for some time from other companies such as AWS. But within Atlassian, we execute TechOps in 5 steps. The first is to develop some measurable goals that you want to work towards with respect to operational health. And so for my team, when we first started, we wanted to reduce the number of noisy alerts that we were receiving because it was getting pretty out of hand. You then sit down and collect some data over the course of the week to help track how you are progressing in reaching those goals. So for our noisy alerts case, we just looked at all the alerts that we'd received that week. With that data, you can prepare a report. So a good example of a TechOps report is a summary of all of the alerts that you'd received, a screenshot of all of your dashboards at a point in time, and then also a summary of all of the notable events and incidents. So at the end of the week, you then take that report and you sit down and you have a discussion with your team. And the idea is that whilst going through that report, your team would start to raise questions and identify actions. And we found that in having these discussions, a lot of really, really useful conversations would come up. We would start asking ourselves whether or not each of our alerts was actually actionable. So were they indicative of a real customer-facing problem that we could actually do something about? We would question how discoverable all of our operational resources were. So during an incident, did an engineer feel as though they could quickly and easily find everything they needed? And we would question how useful all of our stuff was as well. So did we collect things that nobody ever looked at? And conversely, did we have blind spots? And in having all of these conversations, we started to identify quite a number of actions. And we did this every single week. And the data kind of spoke for itself. So in addressing all of those actions, this is the real data of the first 21 weeks that we had of TechOps, showing the number of incidents that we had over time. And we were far from the only team experiencing these benefits. So how can you know that you're measuring the right things? Well, we found that you kind of just need to review those things, and not just once, but frequently. It turns out operational health is not a one-time thing, but something that constantly needs to be reviewed and iterated on. Okay, so we've figured out what to measure and we've got this good process now to make sure that we're still doing the right thing. But when we rolled this out, all of a sudden, there was a lot of change because now we were agile and iterative and everything was getting better all the time, and that's awesome, but sometimes somebody would define the new amazing dashboard, but you had no idea they did that. Or somebody would go and update your monitor to have a completely different threshold, and you had no idea that change had occurred. And so within this section, we'll just speak about how we try to be a little more proactive about keeping up with this change. In the beginning of this presentation, I showed you this diagram where the shard service looks at a variety of different metrics, takes a limiting factor and uses that to denote the overall capacity of the shard. But it turns out figuring out what metrics a shard server should look at was actually a problem in itself. And that was because we didn't really know what metrics were going to be indicative of the capacity. And so we would add a metric and it'd be pretty good, and then we'd have an incident. And we'd add another metric and then have another incident, and add a metric and so on and so forth until things kind of stabilized. And why is that related to operational health? Well, I showed you this dashboard before. Down the bottom there is a subset of all of the different panels that we had to represent the capacity of all of our metrics. And that meant every time we added a new metric, we had to go to the UI and make a manual change. And that was pretty slow and also quite prone to error. And the biggest issue, it was really easy to forget. So you would sort of update your metric in your application and put that up for peer review, and someone would be like, hey, don't forget to update the dashboards, and you'll be like, yeah, obviously, and then 20 other things will happen, and you'll completely forget. And we found that this was very largely due to the fact that there was this huge separation between our application and our operational resources, where our application was this beautiful thing, we looked after it really nicely and we loved it a lot, and then operational resources kind of lived over here, and we looked at them during tech ops and when things went wrong. And so we started to investigate some ways that we can reduce that gap, and we did that by exporting our operational resources into code. We could then take that code and make it live alongside the rest of our application. We then also updated our build pipelines so that every time we were to modify that code, upon commit, we would automatically take it and push it out to the various different tooling that we used internally. And this meant that the code became the single source of truth. We found that this came with quite a number of benefits. To begin with, it meant that everything, our operational resources, were suddenly front of mind. So they were no longer this extra thing that kind of lived on the side, but actually part of our application and part of our definition of done. Having everything in code meant that it was suddenly part of our Git lifecycle. So all of a sudden, operational resources were being reviewed. And if something went wrong, we could roll it back. And it came with the added benefit of making everything much more discoverable, because now everything was defined in one place. And the code was a single source of truth, so it was pretty easy to find out what was going on. So how can you help your team keep up to date with change? Well, we found it really, really beneficial to just start exporting everything into code. And more on top of that, it was just really driving a culture where operational health was actually part of your definition of done, to make sure that people were thinking about it all the time. All right, so we've spent quite a while talking now, and so I just want to take a minute to summarize everything we've covered. To select what to measure, you really just need to learn what questions you want to be able to answer with your operational resources. And that does require you to understand why your application exists in the first place and what failure means to that application. To verify that you're still measuring the right things, you really just need to review those things, and not just once, but frequently. Operations are not a static thing. It's something that you should expect to evolve alongside the evolution of your application. And finally, to help your team keep up to date with change, we found that it was really, really helpful to just start exporting things into code, because it helped drive that culture where operational health is part of our definition of done. And it is worth pointing out that whilst all three of these things are great independently, we found it to be best if they're applied all together. Because after this talk or whatever, it's still going to be hard for you to figure out what to measure. And when you try the first time, it's probably going to be wrong. But if you have this iterative approach and you're constantly reviewing it and finding ways to improve, it's much more likely that you will end up at a point where you can call yourself operationally mature. Thank you.
Hi, that was a great talk.
Oh, thank you.
Could you elaborate more on what tooling and technologies you used for operational resources as code?
Yep, so we use Splunk specifically for logging. We use signal effects for all of our dashboards and monitors. I mean, this is sort of answering the question from a platform point of view. So there are teams independently that might do something different to this, but as a company from a platform, we would use signal effects. In terms of the tooling as well to help with some of that, everything in code, we do have a platform service that we've actually built to sort of know about all the different tooling that we use internally and to kind of abstract away the extracting things into code and automating to push to our different tooling as well. And we use Terraform quite extensively as well. Yeah.
Any other questions? All right, I have one, but this is only for my students.
Yeah.
Can you tell us of any instances where things have just burned completely?
Oh, yes. From just like at any point in time?
Yes.
So yes, we did have, I'm just trying to like remember all the details. We did have cases where we do heavily rely on AWS. And the team that I was on previously that maintained shard service. So that team was an infrastructure team. We maintained like sort of like 13 really critical platform services. And so there was like a lot of stuff going on. But one of those services is a very fundamental service that if it went down, we actually can't serve any requests in Atlassian Cloud. And there was a case where there was an outage, not a full outage, but a massive degradation in DynamoDB, which we rely on very, very heavily within US East. And the request slowed down so much that we couldn't serve anything. And we were waiting and waiting and waiting, and like all our requests to that started timing out. So we failed back to one of our other regions. They had a very similar issue in US West. And so that was kind of on fire as well. We did have a final availability zone that we had, but then the requests across the entire Atlassian Cloud fell onto that, and then it put it under a lot of strain. And yeah, so we've had like that particular service, I think is probably where most of the time things have been on fire, and we've had other cases where our load balancers didn't scale up fast enough for various different cases. And yeah, so that's probably the best example. To solve that particular case with Dynamo, we just cached a lot to try to avoid having that same issue again. We also increased our region presence, and we updated our fallback sort of logic so that currently we sort of had this design where everything had a secondary region, but that meant that if that one thing failed, then everything fell back. And so we try to be a little bit more intelligent about how we did that as well. Yeah.
Brilliant. All right, let's thank Carmel. And I believe we're due for afternoon tea either through this door or through that door. Thank you.